Hi all, in this video, I'll explain you a simple example on interrupts. In this video, I'll explain you how to trigger a manual interrupt and how to execute the corresponding ISR in ARM-CORTEX-M4. Here see, we have one peripheral in STM32 F407 board, that is UART3. In this example, now I'm going to use this UART3 as a interrupt unit, which means this UART3 will generate interrupt to the NVIC. And before going to generate the interrupt from the UART3, first thing you have to configure UART3 as a interrupt trigger unit, or you have to configure UART3 for interrupts. But in this course, we are not going to touch any peripherals of STM32 F407. Here, simply I will enable the interrupt from the UART3 side, and I will handle that interrupt at the processor side. I will manually enable the interrupt. This interrupt will not be enabled by the occurrence of some event at the UART side. I will manually enable the interrupt from the UART3 side, and I will execute the corresponding ISR. I will show you how to do this thing. Now, see here, whenever you want to trigger or whenever you want to get any interrupt from any peripheral, first you should consider what is the IRQ number, interrupt request number. Here see, now we are going to take interrupt from the UART3. So the corresponding ISR number is 39. Where to check the corresponding ISR number means, if you want to check the ISR numbers, you have to go to the STM32 F407 Discovery Board Reference Manual, because even though it is ARM-CORTEX-M4, I am using the ARM-CORTEX-M4 inside STM32 F407. So you have to refer the vendor specific reference manual, not ARM-CORTEX-M4 thing. Here, it is a reference manual of STM32 F407. I will give you this link in description. Here see, this is the vector table for STM32 F407. Here in the vector table, you will get the IRQ numbers for every interrupt. Here, let me show you. Here see, this is a UART, right? See, this is a UART3, and the corresponding IRQ number is 39. Okay. Now, let me go back to the processor. Here see, from UART3 we will get interrupt to the NVIC, and at the NVIC side you have to configure two things. One is pending register and another one is interrupt enable register. Okay, this pending register will pend the interrupt of UART3, and this enable register will enable the interrupt at the process side. Whenever you enable both these things, then that particular interrupt will be processed by the CPU. Now, let me explain you the steps to program an MCU peripheral interrupt. Here are few steps you have to follow to program interrupts in MCU. First thing is, you have to identify IRQ number of peripheral by referring to the MCU vector table IRQ numbers or vendors, which means if you want to configure any interrupt at the processor side, first you should know what is the IRQ number of that particular interrupt. For that IRQ number, you have to go to the vendor specific reference manual. From there, you can get. Just now I showed you. And the next one is program the processor register to enable the IRQ. Only when you enable the IRQ, the processor will accept the interrupt over that line. Which means, if you want to enable that interrupt, then you have to go to that corresponding the processor registers. That is nothing but NVIC registers, and you have to enable that IRQ number in that NVIC register. And the next one is configure the peripheral, that is UART3, using its peripheral configuration registers. For example, in the line number 32, 39, which means if you want to get interrupts at UART3, you have to do interrupt configurations in UART3 configuration registers. But in our case, we are not going to touch any control registers or configuration registers inside the UART3. We will simply manually trigger one interrupt from the UART3 by pending the bit at the NVIC register. That thing I will show you in program, then you will get a clear idea. Now, simply remember, here you are not going to configure any UART 3 configuration register, you are manually triggering an interrupt from the UART 3. Okay. And see here, when the interrupt is issued on the IRQ line, it will get pended in the pending register of the processor. There is one register called pending register. Whenever the interrupt triggers, then the corresponding bit in the pending register will be set to 1, which means suppose this is the 39 IRQ, right? IRQ number 39. For that IRQ number 39, there is one corresponding bit in the pending register. That thing also I will show you, don't worry. So, if whenever that IRQ line, whenever the interrupt occurs in that IRQ line, then the particular corresponding bit will set in the register of pending. Okay. Now see, the next step is NVIC will allow the IRQ handler associated with the IRQ number to run only if the priority of the new interrupt is higher than the currently executing interrupt handler. Which means whenever that bit is pended and the interrupt is enabled on the IRQ number, then your NVIC will allow IRQ handler associated with that IRQ number to run only when the priority is more than the existing one. Okay. Now it may confuse you, but don't worry. I'll explain you clearly everything. Now see, here user RX buffer is there. Now for example, I'm going to tell you one thing. If suppose I'm receiving the data packets from the external world to the UART RX buffer, whenever this UART RX buffer filled, then it has to set the corresponding pending bit of the pending register. Here PR is nothing but pending register. It now see, whenever this UART RX buffer is filled, it is setting this corresponding pending bit. And this is the NAND gate which is present in the NVIC. The two inputs of NAND gate is nothing but one is IRQ enable or not. Okay. So if we configure IRQ as enable and the pending bit also 1, which means that interrupt occurs, now you have to execute the corresponding ISR. Now when both these things are 1 1, then it will send interrupt to the CPU. What the CPU will do? CPU simply fetches the ISR. ISR is nothing but interrupt service routine, which is the function which executes when interrupt occurs. So fetch the ISR address from the vector table. It will fetch the address and PC jumps to the ISR. Here is the sample ISR and it will execute that ISR. This is actually flow. So now what you have to do, if you want to enable or if you want to trigger any interrupts, if you want to make your processor to execute any ISR, you have to do two things. One is, first thing, you have to enable the corresponding interrupt based on the IRQ number. And one more thing is, you have to set that pending bit. Actually, in real time, you no need to set any pending bit, because whenever that UART RX buffer is filled, the processor or the peripheral itself will set this pending bit. But in our case, we are not configuring, we are not touching anything in UART side. That's why it's our responsibility to set this pending bit also. Whenever both this IRQ enable, interrupt enable and pending bit set happens, then it triggers that interrupts to the CPU. Okay, that is the case. Now, let me start writing the code. And before writing the code, here I'll show you the how to enable the interrupt and how to pend the bit. Here see, this is the generic user guide of ARM-CORTEXM4. This link I will give you in description. You can go and get it. Here see, the first register set is NVIC ISR 0 to NVIC ISR 7. This register set indicates interrupt set enable register. If you want to enable any particular interrupt based on the IRQ number, then you have to touch this particular register. The address is this one. Now, let me go to the program. Let me go to the program and let me open it. I already created a project with the name of UART 3 interrupt. Here see, you have to do two things. First thing is manually pend the pending bit of UART 3 IRQ number in NVIC. And the next thing is enable UART 3 IRQ number in NVIC. Whenever you do both these things, then your processor will jump into the corresponding ISR. And before going to pend the pending bit of the UART, first you should know what is that pending register address. For pending register, you have to come to here. See here. This is the pending register. Read it. Interrupt set pending register. So if you want to do, if you want to set any pending a bit, then you have to configure this one. Now, first thing, let me copy this address. And before, there are many pending registers. Observe here. From pending register 0 to pending register 7. Now, based on your IRQ number, you have to select one pending register among these 8. You should not configure any one of the pending registers. You have to select the proper pending register based on your IRQ number. How to select that pending register means, let me give you an example here. Here, you know, our IRQ number for UART 3 interrupt is 39. Here, in each pending register, 32 bits are there. Each bit indicates one interrupt. That means one pending register can configure 32 interrupts. Okay. Now see, this is NVIC ISPR 0. Interrupts set pending register 0. This thing will set the first 32 interrupts. And now our IRQ number is 39, which means you can't configure this IRQ number in the ISPR 0. You have to come to NVIC ISPR 1 because this 39 is present in ISPR 1. So, how to get the exact bit position of that IRQ number is, see here, there are total 32 bits and your bit position is 39. So, simply do mod operation, that is 39 mod operation with 32. That gives you 7, which means you have to set the 7th bit position for pending that particular UART 3 interrupt. Okay, you have to pend the 7th bit position. Now, let me go back to the IDE. So, before this thing, you have to take the base addresses. So, let me write something like this. Interrupt pending register. I will simply write IPR, or I'm going to here and I will take the same name, ISPR. Here, remember, you have to configure ISPR 0 on 1, not 0. That's why I'll give you the name as ISPR 1. And here you have to do 32, do typecasting, and take this address, the base address, and observe this address is ISPR 0 address, but you have to get ISPR 1. Simply add 4 to this address, then you will get ISPR 1 because every register here 4 bytes. Okay, I will simply add 4 to this base address, then I will get ISPR 1 base address. Now, in the same way, you have to take this ISCR also because after pending the bit, you have to enable the interrupt. Then only that interrupt will occur. So, here also in the same way, you should not configure ISCR 0. You should configure ISCR 1 because your IRQ number is 39, which will be present in ISCR 1 in the same way. So, let me do the same thing here. Let me copy the same line. Copy and paste here. Here, instead of IS IP, I'm giving IS here. And here you have to give the address of IS here. Now, take this address of IS here. Here also observe, this address is the address for ISCR 0, not 1. You have to add 4 to that address to get the ISCR 1 address. Okay, that's it. We said, we declared both the addresses. The pending bit. For the pending bit, take this particular thing, that is ISPR1. Now, what you have to do? You have to do the OR operation. You have to do OR operation for setting a particular bit, and you have to shift 1 by how many number of times? I already told you how to get the bit position. Simply uh, do modulus operation here. Here, our IRQ number is 39. I will simply define the IRQ number somewhere here. That is very meaningful. IRQ or UART 3 IRQ. That is nothing but 39. Now, let me take this name and I will use this name instead of 32. And here simply do mod operation with 32. Then you will get the corresponding bit position. Now, I am setting the 1 at the particular bit position. Whenever I set the 1, that particular interrupt will get pended. Now, in the same way, I am going to do in ISER also. Here also do OR operation. And here also shift 1 by this many number of times. So, let me copy from here. Let me paste here. That's it. So, here we are doing two things. One is pending that particular bit and another one is enabling that interrupt. Whenever I will do these two things, then your process will go to the corresponding interrupt service routine. I already told you interrupt service routine is also kind of function. Now, where is that function? That function is not here actually. If you want to get that function name, you have to go to the starter file. You have to go to the .s and here simply search UART3. UART3. Okay. Here see whenever you search UART3, there is one name called UART3 IRQ handler. This IRQ handler is nothing but ISR. Okay. Wherever you see IRQ handler, there you can simply remember that is ISR. Now simply copy this ISR name and let's implement that ISR here. And remember, whenever you are implementing any ISR, please remember the return type and the parameters of ISR should be void. You should not return anything and you should not take anything. That is the case actually while implementing ISR. So here I simply gave the return type as void and the parameters as void. Now I will simply write UART 3 ISR is in execution. Okay, that's it. Okay. I hope everything is clear. Whenever I completed this particular line of code, then our processor should come to this ISR. Now let me build this project. For building, select this project and click on a hammer icon. It is building. I think no errors. Yes, no errors. Now let me go to the debug and let me debug this particular project. Whenever you debug, first it will load your code. While loading, one LED will blink on your board. That is the indication. Okay, it's loaded perfectly. After loading the code, this control will hit to the first line of the main program. Now, let me if you want to see whether all these writes are happening or not in the particular memory location, then you have to go to the show view and here SFRs. And these registers are present in NVIC. So go to NVIC. Now simply click step over, step over. Here see whenever this particular line executes, this line should set 1 at the 7th bit position of ISPR1. Okay. So let me search where is ISPR1. See, this is the ISPR1. Now let me double click it. Here you can see the 7th bit position is 0 only. Now let me click step over. Whenever I click step over, now see the 7th bit position became 1. That means that particular interrupt is pended. Now whenever I execute this particular line of code, then it has to set the 7th bit of ISCR1. Now let me go to the ISCR1. This is the ISCR1. See here the 7th bit position is 0. Now let me click step over and see the 7th bit position became 1. Okay. So both things became 1. Now let me click run. But here observe, it will not hit, it will not come to the UART3 IRQ handler. It will not come. Okay, let me keep one breakpoint right here and let me relaunch the code. Maybe we didn't keep any breakpoint. That's why it we cannot find. Okay, it's loading again. Now I will simply step over, step over, step over, And whenever I step over from here, it should come to the ISR, right? But it's not coming to the ISR. Something is issue here. Now, let me check first the base addresses. This is the ISR1. This is the IRQ number. First, let me check the base address. Whenever we find this kind of issues, first check the base addresses, whether your base address are correct or wrong. Okay. So, first, interrupt set pending register. This is the base address, right? Let me copy this base address. Let me paste here. This is the interrupt set pending register. And here you have to give the number as 4. The next one is interrupt set enable register. That is right here. And this is the base address. Let me copy that base address. And let me paste here. I hope the base address are same. Base address are same. Now, UART 3 IRQ handler. Everything looks fine, but it's not triggering. Okay, let me take one more example. Maybe is there any issue in UART peripheral? I don't know. So let me take one more example. Instead of UART 3, let me trigger interrupt from the ADC. Oh, here we are not enabling ADC. Okay, let me take it from right. Okay, ADC. Let's take ADC. That's not a problem. Okay, now I'm going to trigger interrupt from ADC. The ADC IRQ number is 18. So let me change the, let me write same way. Don't worry, sometimes like this happens. So now I will show you IRQ ADC IRQ number, that is 18. Now for 18, you no need to go to ISPR 1. You can go to the ISPR 0 only, because that 18 is present from 0 to 31. 31 only, the first register itself is enough. Now, here you have to write ADC IRQ, and here also ADC IRQ. Okay, here instead of 1, give 0. That is very meaningful, because you are writing the 0th register, not first register. Okay, it's looking fine. Here, no need to divide it, do mod operation with 32. Okay, everything looks fine. Now you have to write the IRQ ISR for ADC also. For that, first go to, let me terminate the debug. Let me go here and search ADC. ADC. And here you can find the ADC IRQ handler. Copy that thing and write the same thing here. And instead of UART, write ADC. That's it. Keep one breakpoint right here. Okay, everything looks fine. Now, let me build the code for checking how the ADC is working. We have to check whether ADC is working or not. Okay, now let me load the code. It's loading. Let me click run. Yes, see here. The ADC IRQ handler is now executing. That means the ADC interrupt is triggered. Here, in the same way we did for ADC, we simply changed the IRQ number as 18 and we configured ISPR 0 and ISCR 0 instead of 1. Okay. Now, it is hitted to the ADC IRQ handler. Whenever I click on next, it comes back again to the main program. Now, let me show you step by step how it is executing. Now, see, first thing is here the 18th bit of ISPR 0 should be set. Wait, let me go to the ISPR. ISPR 0. See, the 18th bit is 1. And next, whenever I execute this particular line of code, then 18th bit of ISER 0 should be set. So go to here, 18th bit is actually 0. Now, whenever I click on this one, see, it becomes 1. But here observe one thing, whenever you simply click run button, then it is coming to the ADC. See here, it came into the ADC IRQ handler. That means the interrupt is triggered. Now your processor is executing the corresponding ISR. Okay, I hope you understand everything. If you don't get this video, if you don't understand clearly, let me know. I'll give you my mobile number, email ID on the screen. You can contact directly and I will explain you clearly. Thank you. Thank you for watching this video.